So today I will talk about pseudoscalar meson octet and non-net. So for this, let us proceed as follows. So first of all, let us recall quark and anti-quark combinations, right? So let us recall quark and anti-quark combinations. So consider a quark, as we have discussed in the earlier lecture. This is the quark. And you have to see it carefully. It's a right. So this is for quark and this is for anti-quark, right? So say it is a hypercharge axis, this y axis, this is hypercharge, and it is the I3 axis, right? So let us call it as 1 by 2, just call it as 1 by 2, and this as minus 1 by 2. Here it is 1 by 2 and it is minus 1 by 2, and along this axis it is 1 by 3, it is 2 by 3, and here it is minus 1 by 3 and it is minus 2 by 3, right? So that's what we have considered here. So for quark, the value of up quark, it will be 1 by 2 comma 1 by 3, and for down quark its value will be we have to write down it as minus 1 by 2 and 1 by 3, and for the strange quark its value will be 0 comma minus 2 by 3. That's we have to remember. So that means these are the, this point represents u, this point represents down, and this point represents s, or sometimes we simply call it as, right? This is the thing which we have to remember. And if I look back here, then here for anti-quark, the value of these can be written like this, that for u it is minus 1 by 2 minus 1 by 3, and for down it is 1 by 2 minus 1 by 3, and for s it is 0 plus 2 by 3. This we have to remember, right? So that means what are these coordinates? So that means this is basically, this point is basically representing what this point is representing. Sorry, anti-coordinates bar should be there. So u bar is this one, and this point is representing d bar, and need not to write down it in the cut vector. You simply write down it like u, and this also will be written like this, and this can also be simply written by s. So keeping this in mind, we are getting this point, and another s bar point will be this one, right? So these are the points which we are getting. Right. Now let us recombine these. So for quark anti-quark combination, let us proceed as follows. I talked about in the earlier lecture very briefly. So we have to recombine all these things. So for their recombination, we have to proceed as follows. Means now we are interested in q bar. So first of all, let me write down the value of d. The value of d will be this one. D is represented by -1 by 2, 1 by 3, and U is represented by 1 by 2, 1 by 3, and this S is represented by 0, and S is represented by 0 and -2 by 3. Right, means I have considered this. Now for q prime means we have to see the effect of this on this SU and this. So for this, let us do this one. Means S bar, U bar and D bar. So its value will be 0, 2 by 3. Its value will be -1 by 2, -1 by 3, and its value will be 1 by 2 and -1 by 3. So their combination means its combination with all these three. So that means what we are getting, ds, du and dd bar. Means I have to add this into this. So it will be, means I have to add this number into this with this number. So it is -1 by 2 comma, and when I add 1 by 3 and 2 by 3, means I have to add this with this and this number with this number. So proceeding in this way, what I will do means 1 by 3 plus 2 by 3 is basically 1, and similarly when I add this number to this number, it will be equal to -1 comma, and it will be 0, and this is equal to, this is negative, this is positive, and equal, and this is positive, this is negative. So that means it is 0, 0. That's what we are getting here, right? And similarly for the next, again we have to proceed in the similar manner. So it is S, it is 0, 2 by 3. U bar is basically -1 by 2, -1 by 3, and D bar is basically 1 by 2 comma -1 by 3. So their combination can be written like this. So it is 1 by 2, 1, it is 1 by 2 and 1, means US bar and UU bar, UD bar. So it is 1 by 2 comma 1, and its value will be 0 comma 0, and UD bar will be 1 comma 0. That's what we are getting here. Now let us go for the last one, set. So it is SU and it is T. Its value will be 0, 2 by 3, -1 by 2, -1 by 3, and it is 1 by 2, -1 by 3. So finally what we are getting, the values which we are getting is SS bar, and then SU bar and ST bar, and they comes out to be, this is 0, 0, and it will be -1 by 2 -1, and it is 1 by 2 comma -1, right? This is a very important thing which we have to keep in mind. So keeping all these things in mind, we have to plot all these as we have shown in the earlier lecture. So for this, let us proceed as follows. So here it is 1 by 3, it is 2 by 3, and it is 1, and here it is minus 1 by 3, its value will be minus 2 by 3, and its value will be minus 1, and here it is say 1 by 2, it is minus, and it is plus, sorry, minus 1, and in the, towards this side it is 1 by 2, and it is 1, right? So let us mark all these points. So first of all, let me mark this point. ds bar is basically minus 1 by 2 and 1, minus 1 by 2 and 1, okay, minus 1 by 2. So this is minus 1 by 2, and here, so that means this is the point, right? This is 1 point. So let us call it as ds bar. Now du bar will be, so okay, next point will be this one. So it is 1 by 2 and 1, this point will be here, right? Then du bar will be minus 1 and 0, so this point is du bar, and it is us bar is this one, and here dd bar will be, this point will be lying here, right? So it is dd bar, right? And then this uu bar is also lying at the same position, so it is uu bar, and this is 1 0, so 1 0 will be this point, so it is ud bar. Now ss bar is also lying at the same position, so let us represent it is by ss bar, and su bar, it is minus 1 by 2 and this one, so su bar is basically this point. So this point is basically su bar, it is su bar. And similarly, if I look at this point, sorry, this point, so this point is basically this one, st bar. So let us connect all these. So this is basically a type of non-net, because 9 points are represented. These 9 points are represented like this, and let me write down this in the table form. So when I will write down it in the table form, that was written like this, means table representing their values. So let us proceed as follows. So keeping all these things in mind, so for it is q bar, and here I have written the value of i3, and I have written for this the value of this one, so that means us bar, for us bar, and its value will be plus 1 by 2, and its value will be plus 1. For ds bar, its value will be minus 1 by 2 and plus 1, and similarly we have to write down the value of ud minus, and for ud minus its value will be plus 1 and its value will be 0, and uu bar, its value will be 0 and 0. Then du bar, its value will be minus 1 and 0, and for dt bar its value will be 0 0, and then for sd bar its value will be plus 1 by 2 and its value will be minus 1, and su bar its value will be minus 1 by 2 and it is minus 1, and for ss bar its value will be 0 0, right? So these, right, from here I can write down all these values, right? Then let us now recall the mesons. Let us now recall the mesons. So for mesons, I have to proceed as follows. So if I recall, then these two values corresponds to k plus k naught, and this value corresponds to k naught and k naught bar and the k minus, right? Means it is the it's like electron and positron as we have seen, and this is for the particle and its anti-particle, right? Then it corresponds to pi plus and it corresponds to pi minus, these values. And let us talk about another, pi naught, and the pi naught is basically the combination of various quarks, u bar minus dd bar divided by under the root. And if I talk about the values of phi3 and y, because its value will also be 0 and its value will also be 0 0, so if I put these values, then again its value comes out to be corresponding to 0 0. And similarly, here let me talk about eta naught, and some text it is represented by eta 1, and in some text its value will be sometimes written as eta. So it is basically 1 by 3 uu bar dd bar plus ss bar. And if I again talk about, because if I keeping all these three values in mind, then its value again comes out to be 0 0, means it is i3 and it is y, and it is i3 and y is again comes out to be 0. It is like this. Then we will define another, that is eta 8. It is, or sometimes it was represented by eta prime. It is eta 1 and it is eta prime, right? So eta 8 or eta prime is basically, what is it? What it will be? It is 1 by root 6. So uu bar plus dd bar plus minus 2 ss bar, right? This is a way. And for this again, the value of this i3 and y will again be 0 0. So if we now look at this diagram, in the similar fashion we will define this octet or the nonet for the mesons, right? So in octet form they can be defined, or this can be plotted like this. So for the meson octet, we have to do one thing. What was that? I am talking about the Meson octet, means now I am plotting Meson octet. This is y and this is I3, and similarly this is y and this is I3. So it's basically, its value will be 1 and its value will be -1, and here it is 1 by 2 and its value will be 1, and similarly its value will be 1 by 2 minus, and it is -1, right? So corresponding to this, it is the k positive. So k positive will be like this one. So that means what this point will represent? This point will represent k positive, and k minus will be here. So it is SU bar. So it was lying here. It was lying here. So it is k minus, was lying here, right? Then k naught will be here. So corresponding to it, it is k naught, and k naught bar will be here. So it was lying here. So it is k naught bar. Now this is the pi plus, so pi plus will be here. So this point is basically representing pi plus, and this point is representing pi minus, because pi minus is basically du bar, and sorry, it's not a octet, but I am first of all writing it in the form of a nonet, right? Meson nonet form. So that means but if I look at here, then for all pi naught, eta naught, or the eta 1 or eta 8, all the values are at the 0 0. So that means it represents 3 points. One is also at 0 0, another point is also at 0 0, and this one is also at the 0 0. So that means this is basically pi naught, eta 1 and eta 8, eta 1 and eta 8. These all are lying at the 0 0. So that means what this representing, basically they are the combination of all these. Means these 3 particles, pi naught, eta 1 and eta 8, they can be written in the form of a combination of UU bar, DD bar and SS bar. This we have to keep in mind, right? So this is basically nonet representation of the mesons. This is basically nonet representation of mesons, but sometimes this can be taken outside. So in that case, means in the octet form, means in the meson octet, these points are represented and this can be taken outside, right? So in the octet form, we will take 8 mesons. Let me draw it again. So it was like this. So it was like this. So it is y and it is I3, and its value will be 1, its value will be -1, and its value will be 1, and its value will be -1, right? And here it corresponds to 1 by 2 minus ka, and it is the plus 1 by 2, right? It's like this. So that means in the octet form we will represent only these points, as we have seen in the above case. So it is k minus and it is the k naught dash. It is pi naught and it is eta 1. These all are represented, and sometimes eta 1 can be written as eta naught or eta, right? And plus this is the meson octet, and this can be represented separately. So eta 8 can be represented like this. So this is the meson octet. Now, because here I talked about what we call so for these mesons about which I have talked here, means these all are the mesons with total spin 0 and odd parity that is Jp is equal to 0 minus. Therefore these are pseudoscalar mesons. These are pseudoscalar mesons. These are pseudoscalar mesons. Because for pseudoscalar particles this Jp is equal to 0 minus, that means 0 spin, total spin will be 0 and having the odd parity, right? So thus I talked about in this lecture meson octet or pseudoscalar meson octet. So that's all for this lecture.